So the remainder theorem says if you're dividing by a binomial, x minus a, whatever a could be, you can find the remainder by doing long division or synthetic division, or you can find the remainder just by plugging in a. And they give an explanation of why this works. Remember our division statement. Dairy Queen plus the remainder. If you're dividing by x minus 2, for example, this is what it would look like. If you plug in 2, this part would become 2 minus 2. And 2 minus 2 is 0. So 0 times q would be 0, and you would just get the remainder left. That's why the remainder theorem works. Whatever you're dividing by, if you plug that number in, opposite sign of what you have. So here, if I'm dividing by x minus 2, if I plug in positive 2, this will be 0, and you'll just get the remainder. So our first questions, look at this. It says, determine the remainder when each thing is divided by each binomial. And so now you have two choices. So in A, choice number 1 is that we can do synthetic division. 2, negative 5, 5, 5, 3. I checked that they're in the right order. I checked, as far as the setup goes, that no degree is missing that I need to put in a 0. If I'm dividing by x minus 3, I'd put a positive 3 out in front. Bring down the 2, multiply, add, multiply, add, multiply, add. Whew, 3 times 29. Yes? Oh, my second 5 should be negative. Thank you, because that makes my numbers not so bad. Negative 5 plus 3 will be negative 2, multiply, negative 6, add, negative 1. 3 times negative 1, negative 3, add 0. So you can find the remainder through synthetic division or long division. So this tells us the remainder is 0. Or you can use the remainder theorem, and I'm going to go let p of x equal all of that. So the remainder theorem says plug in 3. If I plug in 3, I'm going to get 2 times 3 to the 4 minus 5 times 3 cubed minus 5 times 3 squared plus 5 times 3 plus 3. 3 to the 4, 3 times 3 times 3 times 3, 81 times 2, 162. 3 times 3 times 3, 27 times 5, minus 135. 9 times 5, minus 45. Plus 15, plus 3. And if you put that all together, sure enough, it equals 0. So looking at this example, I actually think the synthetic division was easier, right? If we look at the synthetic division, what was the biggest number we had to multiply? 3 times 2. Difficulty level, pretty low. With the remainder theorem, what's the biggest numbers we had to multiply? 3 to the 4 is 81. 81 times 2, that's pretty big. Or 5 times 27, that's a little bit bigger. So in this case, the remainder theorem is more difficult mental math than synthetic division. Okay? The other nice thing about synthetic division is not only does it tell you the remainder, but it gives you the quotient as well. So there's more information that it gives you. The remainder theorem only gives you the remainder. So generally, I find that I like the remainder theorem to use only if the numbers are really, really small, like 1 or negative 1. Those are my favorites. 2 is already, 2's not bad, but already at 3, you can get some big numbers. So then you might prefer synthetic division. There are some cases where the remainder theorem is the only thing that works. So if you're deciding right now, oh good, I'm not going to learn the remainder theorem, I'll just do synthetic division. No, you still need to know the remainder theorem because there are some questions that only the remainder theorem will help you. Okay, let's look at B. Same thing in B. We could use synthetic division. So if I was doing my synthetic division, 2, -5, -5, 5, 3. Now I'm dividing by x plus 2. So I'd have a -2 out in front. Bring down the 2, multiply, add, multiply, add, multiply, add. Oh, a little bit bigger numbers this time with synthetic division. The remainder theorem, P of 2 says it's 2 times 2 to the 4 minus 5 times 2 cubed minus 5 times 2 squared plus 5 times 2 plus 3. 2 to the 4 is 16 times 2 is 32. 8 minus 40. 4 minus 20 plus 10 plus 3. Okay, and I got different numbers here. So where did I make a mental math mistake? Did I copy the question down right this time? Yes. Minus 2. Five. Oh, no, that's good. Where's the minus 10? Right here? Is it minus up there, though? Oh, it's plug in minus 2. Okay, there's my mistake. I have to plug in minus 2, the opposite sign. So these would all be negative, 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 and negative. Because we're dividing by x plus 2, this is always the opposite sign. Checking this out, this will still be 32. This is negative 8 times negative 5, which will be positive 40. Positive 4 minus 20 minus 10 plus 3. So 72, 75 minus 30, 45. So once again, about equal, probably the synthetic division was easier. But we can get the remainder either way. Okay? Questions for practice on this one are 4a, 6a, 7, and 8.